The formula used to calculate shear stress caused by torque is Tc over J, with the following values being in the equation, namely the internal torque, the distance from the center, usually a maximum value, and the polar moment of inertia, which is basically your inertia multiplied by 2. This equation is typically only used with circular shafts. We usually want to draw a torque diagram to help us know what the internal torque will be at specific points. Power can then be determined by using this equation, where the power is equal to torque times omega, and omega is equal to the rotational velocity of the shaft. When you think of a stress distribution of torsional loaded objects across the cross-section, you must understand that the stress increases the further and further you get out from the diameter. If we had a shaft that was loaded like this, we would then have a torsion diagram that looks like this on the inside. Power transmission is important to know because power remains constant. The units for power are kilowatts or horsepower. Each one of these have unit conversions to more known units, like Newton meters per second and feet pounds per second. Usually we need to focus on unit conversions when dealing with power, especially on focusing with the revolutions and the horsepower. Here we have an example problem with a motor. We are trying to design a shaft that can withstand 3 horsepower and 300 RPMs. First, we will want to use the power equation and do our unit conversions to find the supplied torque, which is going to be doing the following. Or we get 630.25 inch-pounds. Next, we will want to use the formula to find the shear stress in the shaft, and symbolically represent the diameter with d. Then we will set that equation equal to the allowable shear stress. We can then solve for the diameter by moving it over to the top and moving the allowable shear stress to the bottom. And then solving for the diameter, we will round to the nearest inch. Since our final answer is 0.451, we will round up to half an inch. It is always better to be safe than sorry.